Good morning. How is everybody today? So my name is Kim Konzak. I will be an instructor for Million Statistics, and you will find that learning math is a lot of fun. So I have been teaching for 25 years, mostly the high school level, 9th, 10th, 11th, 12th. I've also taught adult education through Great Neck, and I'm an adjunct at Adelphi University. So I think you're in good hands, and I hope to make math fun. I post the syllabus, some homework every week. Make sure to complete that homework, as it is 20% of your grade. So all the expectation is also an email address where you could contact me with any questions or concerns. So I am here for you. Please make sure you use me as a resource to help you learn. So we're going to start off with probability this week, and how incredible it can be in helping us learn about the world around us and just about the chances of things occurring. So let's take a look at a little video about probability. So I'm going to go through all these terms with you, but I'd like you to see this here because they'll give you some visuals as to where probability is used.
Flipping a coin are all things, and these are often used to discuss the basic concepts of probability. There are four key terms that are often used with probability. A probability experiment, which is a process such as rolling a die, as there are only 6 possible outcomes. An outcome is another key term, which is a single result of a probability experiment. So if you draw a 4 of hearts from a full deck of cards, that is an outcome. Sample space is another key term, and it is a set of all possible outcomes for a probability experiment. The sample space for rolling 2 dice is here, and you can see the possible outcomes for die 1 and the possible outcomes for die number 2, and the sample space is the pairs of numbers listed here. So there are 36 possible outcomes in this sample space. Event is another key term used in probability, and an event is a set of outcomes of a probability experiment, subset of the sample space, and an event with one outcome is a simple event, and a compound event consists of 2 or more outcomes. For instance, the event of rolling a 4 on a die roll is a simple event, and the event of getting an even number on a die roll is a compound event. There are 3 main types of probability: classical probability, empirical probability. Classical probability is used when each outcome in a sample space is equally likely to occur. For instance, the sample space for rolling 2 dice, and each of these outcomes has the same chance to occur. The formula for this is P of E. Probability of any event equals the number of outcomes in event E divided by the total number of outcomes sample space. So the probability of the 2 dice totaling 5 is P of 5 equals 4, the number of possible combinations that total up to 5, divided by 30 outcomes in the sample space. Empirical probability is when each outcome is not equally likely to occur.
Okay, so we're going to first at classical probability. Okay, and I know that that video went very fast, but I'm not going to be going that fast. I'm going to be sharing my whiteboard here. Okay, terms that you need to know. Okay, so that it becomes much easier for you. But again, I just want you to kind of see how other people approach probability. Okay, so what we're going to start with is usually when we have probability, an experiment. So let's write out some of these words and these terms. Okay, so an experiment is an activity in which results are observed. Okay, and why are we talking about experiments here? Well, we're going to perform experiments like rolling a die or tossing a coin, and we're going to see the outcomes that can occur. And in this case, we're going to be talk about outcomes that are really likely to occur. So that's an experiment. And you probably have heard the word experiment. Where have you heard the word experiment used? Okay. When you do an experiment, each round of an experiment is called a trial. So they may say how many trials will be in your experiment. And the more trials, the better, right? Because obviously, when you do something more and more and more, you'll get better results in probability. And I'll show you why. Okay. And then a trial, the result of a trial is called an outcome. We want to know, are we getting heads? Are we getting tails? Now, as you saw in one of the, okay, and I'll just let you catch up. But as you saw in one of the videos, they were talking about at the beginning with that cute little song there, right? They were talking about what probability is, likely, unlikely, certain, uncertain, probability of an event, the probability of an event, okay? Usually they write the probability of an event like this. That symbol stands for the probability of an event. So probability of an event. Okay, now that probability is a number between 0 and 1. Between 0 and 1. What that means is if it's not likely or impossible to happen, probability is 0. If it's certain to happen, the probability is 1. Okay, and then in between 0 and 1, okay, let's say we have 0.5. Okay, so 0.5 means that there's a pretty fair chance of the event happening, right? It's kind of like right in the middle of the two. 0.8 is very close to certain. 0.3 is very close to impossible. Okay, now let's just talk about those numbers because I don't know how much you know about decimals and fractions. So when we talk about probability, we can express it as a fraction, we can express it as decimals. So for instance, if I say the probability of an event is 1/2, that's the same as saying that the probability of the event, E in this case, right, is 0.5. Okay, so you will see probability expressed in many different forms. You'll see probability expressed as a fraction, and you'll see it expressed as a decimal. The fraction cannot be over 1. That doesn't make any sense because 1 is that the event is certain to occur. Okay, so again, what is probability? What is probability? Probability is the likelihood occurring. So let's just write that down again. Probability is the likelihood of an event occurring. Okay. And again, ratios, fractions, decimals, percents. And in order to calculate probability, we're going to have to know how many outcomes there are. Okay, so let's take a look at some possible examples that you can get so that you understand more about. Okay, so let me share our little Cami app here. Okay, so now we're going to take a look at some examples and let's discuss them together. Okay, so it says answer each question below based on the experiment described. Okay, you flip a coin. That's an experiment. Okay, when you flip a coin, how many outcomes are there? When you flip the coin, it can land on what or what? Heads or tails. So there are two possible outcomes. Two possible outcomes. Now, are the outcomes equally likely to occur? Meaning, is getting heads equally likely to occur as tails? Yes. Unless the coin is weighted, there are things called weighted coins, then the probability will be different. But we're not talking about bias here. Bias means that there's something, some kind of event or occurrence within the experiment that is causing it to not come out in a fair manner. Okay, here we go. You roll a pair of dice. Okay, and again, die is singular and dice is plural. So you roll a pair of dice and find the sum. Possible outcomes. Okay, now possible outcomes when you want to find the sum. Now this is a very interesting to think about. Okay, because if you're rolling a pair of dice, and eventually I'm going to show you how to use a tree diagram to find an example like this. But if you're rolling a pair of dice, okay, and let me just stop the share for a second and go to my whiteboard here. Okay. So on the first die, I'm going to make a little table here. Okay, on the first die, you could roll a 1, 2, 3, 4, 5, 6, correct? And again, I'm going to terms and all these strategies as we go along in the course, but I want to kind of show you how to think in probability terms. Okay, now on the second coin, and this is the first coin. I actually do tree diagrams, which are a lot of fun. Okay, now on the second coin, you could roll a 1, 2, 3, 4, 5, 6. Now, if you want to see the sum, if you roll, right, if you roll a 1 and a 1, something that's blocking my thing here. Okay, a 1 and a 1, that'll be an outcome of 2. If you roll 1 and 2, that'll be an outcome of 3. Now, I don't want you to fill this chart in right now because we're not up to that yet. I want you to think how many possible outcomes. Well, there are 6 outcomes on the first roll. There are 6 outcomes on the second roll. So how many boxes do we have here? Count how many boxes. So 2, 4, 6. So 6 across, and outcomes is that? 6 by 6 is 36. So there's 36 outcomes. Now that's going to be called something that's going to come up soon. It's going to be called the counting principle. Let's write it down now. I'll write it down again. Okay. So the counting principle says, I'm going to change some colors here. The counting principle says if one event can occur in m ways. I know we start using variables, letters which represent numbers, m ways, and another event can occur in n ways, then the two events can occur in m, and I don't like to use the x for multiplication, right? So m, but I'm going to here, m times n ways. So that means we're multiplying. We're multiplying the chances of the first event by the second event. Okay, and again, I'll give you a second to copy that down, and we'll be explaining some about the counting principle, which is going to come up as we study probability. And I'm going to show you how to apply it. So don't, if at first you don't understand, what it means, but this is the counting principle, in probability. Okay, so now let's go back to our Kami doc, okay? And here we go. Stop my share and let's restart my share. Here we go. So when we rolled the pair of dice and we found the sum, the possible outcomes we said were 36. Now, what would be an impossible outcome, right? So the possible outcome, there were 36 possible outcomes. Okay, now an impossible outcome is one that could not occur. We couldn't get sum, right? We couldn't get that sum. So that would mean if we went back, right, to this, to the whiteboard here, okay, and we did fill this out, okay, could get, for instance, you don't have to fill it out now, but just think to yourself, could we get an outcome where the sum of the die is 18? Is that possible? No, because the biggest numbers on the die are 6 and 6. So we could not get that the sum of the two numbers is 18. So that's a possibility, and that's an impossible outcome. Impossible. And what's the probability of an impossible outcome? We said is zero. Okay, is everyone following? Okay, I know it's a lot, again, for the, the first day, a lot of a lot of terminology. Play if you need to, but again, it'll be in a lot of the notes that you'll have, and it'll also be in homework. Okay, all right, so now a bowl contains 15 red marbles and 5 green marbles. Possible outcomes here are what? The possible outcomes are either getting a red marble or a green marble. Okay, what's the most likely outcome? What's the most likely outcome? If you have, now think about it, you have more red than you have green. So what do you think is more likely to occur? Getting a red. Very good. Getting a red. Okay, number 4, 20 names are written on the slips of paper in a basket. What are the possible outcomes? The possible outcomes, there's 20 possible outcomes, right? And they're going to be names on the slips. And there's 20 names and 20 possible outcomes. Okay. Now, the outcomes equally likely. Okay, as long as none of the names are repeated, okay? So in other words, every single person in this course has their name on the slip and no one's name is repeated, then outcomes are equally likely. Okay, if someone's name was repeated, then it would not be equally likely. Okay, so let's keep going and we'll see where we go with this here. Okay, so this is what we were talking about before. So outcome is the result, a possible result of an activity or experiment, and probability is a measure of how likely is that specific outcome when it occurs. Okay, so this is very, very, very important, this little formula here. And again, I don't want you to memorize a formula. I want you to through it. Okay, so the probability of an event is the number of specific outcomes over the number of. It's what you're looking for out of the total number of outcomes of what can occur. Okay, and we can express this in many different ways. So make sure you've copied this probability formula into your notes, and then we're going to work from there. Okay, are we ready? And then we'll take like a little video break as well. Okay, so here we go. Find the probability, express your answer as a fraction in simple form. They want us to reduce the fraction. If you're not familiar with reducing, I will accept answers in non-reduced form, but you should have familiarity with reducing fractions. Okay, so if you spin the spinner at the right, what is the probability the spinner will stop on each of the following? What's the probability the spinner will stop on a number? So first thing you want to do is you want to count how many outcomes. There's 1, 2, 3, 4, 5, 6 outcomes, right? So I always write that on the side here for myself, 6 outcomes. That's going to be my denominator in the fraction. Denominator is the bottom number, the number of outcomes. So 6 is going to be in the denominator. Okay, that's called the denominator. Denominator of a fraction. Denominator. Okay, now a number. How many of these are numbers? Well, we have 4, 5, and 6. So 3 are numbers. So it's going to be 3 out of 6, 3 possibilities out of 6, which reduces to 1/2. 1/2. Does everyone know how to reduce a fraction? I'd like some feedback about that. If you don't, please either message me, email me. Let me know. I can give you some more practice on reducing fractions as well. Okay, and again, the top number in a fraction is called the numerator. The numerator. Okay, here we go. Let me give you a couple minutes and see if you can try the next ones on your own from 2 to 8. Let's also discuss, though, before you do that, what an even number is and an odd number is, just in case. An even number is a number divisible by 2. Okay, so 0, 2, 4, 6, 8, those are all even numbers. An odd number, 1, 3, 5, 7, 9, those are odd numbers. Okay, and then in the alphabet, which has 6 letters, right, we have our consonants and we have our vowels. The vowels are A, E, I, O, U. Okay, and then our consonants are everything else. Typically, sometimes you'll hear like Y is considered a vowel, typically with probability. And I, right? So we're not worried about Y. We're worried about A, E, I, O, U. Okay. So try numbers 2 to 8. And I'll give you a couple of minutes. And as you do that, we'll, think about the answers, and then I'll fill them in with you, and we could take it from there. Okay, so let me just put on some relaxing music as you work. I'm very into it being a nice, calm environment when we learn math together. So you look forward to coming to class, because I know I do. And the one thing about math, not to interrupt, is that the more you do math, the better you get at it. Okay, so that's one thing, practice makes perfect. Okay, so let me just turn that music off now, just so we can get back to our example here. Okay, so here's our example again. An even number. So let's see what we got for an even number. An even number here is 4 and 6. So we should have 2 out of 6 or a third. Did anyone get that? 2 out of 6 or a third? Okay, hope you did. And okay, how about an odd number? Okay, so I see one odd number, 5. So that would be 1 out of 6. 1 out of 6. Okay, what about a consonant? A consonant, okay, have D and F. D and F. D and F are consonants, correct? So that would be 2 out of 6. Or okay, how are we doing? How are we doing? Okay, I hope well. Okay, what about a vowel? A vowel. Okay, so a vowel, I'm gonna try to stick with pink here. Okay, I don't like red because it's too harsh. Okay, a vowel is 1, right? 1 possibility out of 6. 1 possibility out of 6. We just have the E there. Okay, about getting the number 6. Well, there's 1 6 on the spinner, so 1 out of 6. Okay, a little trickier, but you have to think. A number, do we know the symbol, what the symbol means? This symbol means less than 6. So if you didn't know that, this symbol means less than. So less than 6 would be 4 and 5. 4 and 5. Didn't say equal to 6, so you can't include 6. So 4 and 5 would be 2 out of 6 or a third. And a number greater than 6, a number greater than 6. Okay, so is there any number greater than 6 on the spinner? Nope. So 0. That means impossible. That's an impossible event. An impossible event. Okay, let's try a little bit more and let me show you how we can put the concepts together, because sometimes in these examples they'll use the word or, and or is going to indicate addition. So when you see the word or, it's going to indicate addition. Okay, so let's take a look. It says solve the problems based on one spin of the spinner. So again, we're only spinning one. At some point, we're going to spin more than once. Those are going to be independent or dependent events. That's going to be different. It says express each probability as a form. Okay, so first of all, how many possible outcomes can we have? When we look on the spinner, we can spin 1, 2, 3, 4, 5. So the number of outcomes is 5. Notice it's not a fraction because it's asking you how many possible outcomes you can have. Okay, now it says the probability. Probability is the chance of stopping or chance of something occurring. The probability of stopping on 4 is what? How many 4s are there out of the total number of outcomes? So there's 1 4 out of 5 outcomes. Does that make sense? 4 out of 5 outcomes. 1 4 out of 5 outcomes. The next one says the probability of stopping on an odd number, Okay, so how many odd numbers are there? Think about that. So we have 3 odd numbers. So out of our 5. What are our numbers? 1, 3, and 5. Now, this is very interesting what's coming up here. We're going to talk more about this later, but this is the complement of an event, it's called. Not the complement. So there's a couple different comments that I could pay to you and say, thank you. I compliment you for paying so much attention in my class, right? That actually just go off on this for a second, only because it's kind of important just to life in general. Okay, that compliment is spelled, I always remember it with an I, because it's like, I like you, thank you for doing that for me, compliment, when I pay you a compliment. Then there's something called a complement, okay, as well, sound the same, spelled differently, okay? This one has an E in it, okay? That's like saying, oh, your pants complement your shirt, okay? Or in math, the complement of something happening is, well, I'll show you use example. So hold on one second, let's go back to this. So here it says the probability of not stopping on an odd number, not stopping. So the probability of stopping on an odd number was 3 out of 5. Not stopping on an odd number is the complement would be stopping on an even number, in which case it would be 2 chances, 2 out of 5. There is a formula for finding the complement of an event. It's just subtracting it from 1. So for instance, if I said to you, the probability of snow today is 1 out of 7. The probability of no snow would be out of 7. So we'll eventually talk about complements a little bit more as well. Okay, I just wanted to throw that in there. So when you hear it, again, it'll be like, oh, I've heard this. Okay, the probability of stopping on a 5 or a 3. So that's technically like saying the probability of the 5, okay, which we talked about, which is 1 over 5, okay, or the probability of a 3, which is 1 out of 5, which would be 2 out of 5. So again, you could just say, well, I'll just take the 5 and the 3, put them together. There's 2 possibilities. You could do it like that. You could add the separate fractions. Remember, when you add fractions, you keep the same denominator. I just wanted you to make sure that you were familiar with when you hear or in probability, it's going to be addition. Okay, so or in probability, addition. Okay. And then the probability of stopping on a number greater than 1. Okay, so here we go. Greater than 1. So greater than 1 would be 2, 3, 4. How many outcomes is that? 4 outcomes out of 5. 4 outcomes. Okay, so how are we doing so far? Are we doing a yay? Are we doing a nay? I hope everything's doing good. I'm putting up some reactions for yay. I have a little reaction up here, yay. Okay, anyone, a little clap for you, yeah. I hope everything's going well. Okay, I'm going to give you a little cheer up there. Okay, so let's share the screen again. Okay, and let's go down here and try a problem together. Okay, 7, 8, 9, and 10. Let me set you up to try it. It says a bag contains 3 pennies, 2 nickels, and 4 dimes. You will select a coin at random. Okay, so I'll actually start it with you and then try from 7 to 10. You're selecting a coin at random. The word random in probability is very important. Things need to occur at random for the event to be considered valid, okay, and not biased, okay? And we're going to be talking about randomness in statistics as well. Okay, so number 7 asks about the probability of choosing a nickel. 8 is a penny or a dime. 9 is not a penny. And 10 is that it's worth more than 10 cents. Okay, so you have to know the value of the coins as well. But remember, when you start probability, always think of the outcome, the sample space. How many outcomes can occur here? And you get by adding, in this case, all the different coins. Okay, so I'll give you a minute to work on that.
Cold is gone.
Okay, so let's go back to our Cami. Let me just make sure that you can see the Cami here. I'm often afraid sometimes that the wrong video shows up. Okay, so it says the bag contains 3 pennies, 2 nickels, and 4 dimes. You will select a coin at random. The probability that you would choose a nickel is, okay, so how many nickels are there over how many coins? So first of all, let's add up the number of coins. So there should be 9 coins, correct? So 9 coins total. And what's the probability of choosing a nickel? There's 2 nickels out of 9. Okay, and that one you can't reduce any further. So that you will choose either a penny or a dime, So what's the probability of a penny? The probability of altogether, how many pennies and dimes are there? There's 7 out of 9. The probability that you will not choose a penny. So if you're not choosing a penny, you're choosing a nickel or a dime. And there's 6 of those. So that's 6 out of 9. Now, you can reduce that if you divide each of them by 3 to 2/3. Are we okay with reducing it? And then the probability that you will choose a coin worth more than 10 cents. Okay, so here, which coin is worth more than 10 cents? The penny, the nickel, the dime? None of them. So that means it's zero. So the probability of choosing a coin worth more than 10 cents is zero, and this means it's impossible. Impossible. So how are we doing so far? We're doing okay? Okay, so just as a little review, I just want you to see this little video here. I thought it was very cute and helpful.
Probability is like chance of something happening. Some of the important vocabulary we need to know: the words impossible, which means it will absolutely possible, meaning it could happen, or certain, meaning it absolutely will happen.
So remember, the probability of a certain event is 1, the probability of impossible then is 0.
So here are some examples. What is the probability that you will turn into that? Impossible. What's the probability that you will eat food today? It's possible, right? Gonna happen, but you never know. That your heart will beat. That's certain. As long as you're alive, your heart will beat. The sun will rise. Also certain. You will win a trip to Mexico today without entering a contest. That's pretty impossible. It's not gonna happen. Now, there's also some vocabulary we need to know for when we're comparing two different possibilities. So is something less likely to happen, equally likely, which means the chances are exactly the same, or more likely? So some examples we can look at. What is the chance that you will flip a heads or a tails on a coin? It's equally likely. There's one head, one tail. In theory, the chances should be exactly equal. What's the probability that you'll draw a face card versus a number card and deck of cards? So remembering, there's just a jack, a queen, and a king for face cards, and there's ace to 10 for the number cards. You're less likely to draw a face card. There's more number card.
Okay, so I don't know how much you know about the deck of cards, but we'll be throwing that in periodically. Don't worry if you don't know about the deck of cards, it's okay. But there are more number cards than face cards. So that's what they're saying, is less likely to draw a face card.
You will pass your grade versus fail it, or likely to pass. You will get picked up in a helicopter for school versus riding a bus. You're less likely to get picked up by a helicopter. So what are some probability tests that we can do? The first one you can do is roll a dice. If you roll your each number, should you have an equal chance to roll each? In theory, yes. Your dice has 1 to 6 on it or 1 to 10 on it. You should have an, do you? If you rolled it 10 times, would you roll each one the same number? Play rock, paper, scissors. How many times did you win? Flip a coin. How many times head or tails? Draw a card and try to guess if your next one will be higher or lower than your last one. Or take a spin on a probability spinner. So this is an example of a probability spinner. If you look at this spinner, I've made it so that yellow others are small, which means that we should have a higher chance, or it's more likely to spin yellow than the other colors. And then it's equally likely that you spin your purple, your red, and your cyan. But when I spun them 10 times, I got 8 yellows, 1 blue, 1 purple, but no reds or cyans, because probability is a guess or a chance of something happening, but it's not necessarily going to happen when we do it. And then here we have 5 equal ones. So in theory, we should have an equal chance of getting all of them. But we did 1 blue, 0 yellows, 3 cyans, 5 reds, and 1 purple. So half of my spins landed on red, even though in theory, we should have had an equal chance of getting all of them. But in this case, it was more likely that I got red for some reason.
So this I talked about earlier. So technically we should get a fifth for each color, but we didn't do a lot of spins, right? She didn't do a lot of spins of the spinner here. Because she didn't, you could kind of see that there was more red. The more simulations you do, the more times you do the experiment, the better outcomes you get.
So that's probability. That's a quick introduction that will hopefully help.
Okay, hope you enjoyed that. Okay, so let's just get back to one last thing in our CAMI files. Okay, so we go back to our CAMI files. This was the last thing I wanted to talk about, full circle for this lesson. We talked about events, right? An event is a set of possible outcomes from an activity or experiment. And we talked about sample space is what outcomes can we get? If we roll a die, we can get 1, 2, 3, 4, 5, or 6. Sorry, if we roll, yes, a die. If we toss a coin, we can get heads or tails. Okay, so we were able to add the probability of the two events right here, to add the probability. If the events were called mutually exclusive, that means events cannot occur at the same time, meaning I can't throw a head and a tail at the same time. So I can add the separate probabilities. Okay. And then we had complementary events. So complementary events are events that together make up the entire sample space. The probability add up to 1 or 100%. So they are mutually exclusive, but not all mutually exclusive events are complementary. So we'll get into that, don't worry. Okay, so all we did, and this is the symbol for complement. It's an A with like a little prime symbol. I'm not going to hold you responsible for that, but I want you to see it. That just means, so for instance, if I say the probability of you having homework tonight is 1/3, what's the probability of not having homework is 2/3. So you're doing 1 way 1/3. Okay, let's just do some problems with that and then we'll wrap up. Okay, determine each probability. Express your answer as a fraction in simplest form. On one roll of a 6-sided die, what is the probability of getting a 1, 2, 4, or 6? So those are mutually exclusive. Like in other words, you're only going to get one of those at a time. If they're mutually exclusive, or you're going to add the separate probabilities. So the probability of a 1 is a 6. The probability of a 2 is a 6. The probability of a 3 is probability of 4 is a 6. The probability of 5 is a 6. And the price is a 6. So getting a 1, 2, 4, 6 would be 4 out of 6 or 2/3. Okay, are we okay? All right, so a bag holds 3 red marbles, 2 green marbles, and 3 black. What is the probability of not choosing a black? Okay, so all together, let's see our sample space and our total number of outcomes. Our total number of outcomes are 8, right? So 3 plus 2 plus 3 is 8. We don't want to choose a black marble. So I'm going to choose a red or a green, which all together is 5/8. Good. Okay. Events A and B are mutually exclusive. Okay. So when it says that and it gives you your or, what are you going to do? What is the probability that either A or B will occur? That means we're going to add the probability plus the probability of B. Now, again, I don't mind you using a calculator if you have to, or you can get a common denominator. The common denominator is 10. So this is 3/10. And then this one, you'd have to multiply by 2. So So 3/10 plus 2/10, which would be 5/10 or a half. 5/10 or a half. Okay. And then it says events. Okay, so let's think of that word, mutually exclusive, can occur together. Okay, events X, Y, and Z are complementary. The probability of X is 1/8, the probability of Y is a half. What is the probability that Z will occur? Okay, so if they're all complementary, that means they all add to 1. Okay, complementary means all the probabilities add to 1. So what we want to do to find the probability of Z is take 1 minus the probability of X minus the probability of Y. So 1 minus 1/8 minus a half. And again, depending on what your skills are, if you need to use a calculator, I'm totally fine with that. Or if you get a common denominator of 8, this would be 8/8 minus 1/8 minus 4/8, which would be 3 out of 3/8. Does that make sense? Everyone okay with that? It's a pleasure to have and meet you this week. I know I'm not meeting you in person. Please reach out to me. Let me see if I could find a cute little video to end. Had a bunch in my little files here. Okay, so I hope you enjoy this cute little video I found. The probability of something cool. Maybe let's go. So what's the chance? I toss a coin and it lands. Yes, I definitely feel my plans. I don't want it, but I want chance. Yeah, so I'm thinking through the possibilities. I throw my hands up in the air, saying, hey, don't you know the probability of something cool? Thinking, hey, baby, let's go. Arrow to possibilities, the coin can land. Either hit or tail, that's probability. And one of those two choices was the tail I wanted. Someone overtook the probability. So what's the chance? The card I picked from the standard pack. It's a mix there are 4. Pieces out all 52 cards. Yeah, so I'm thinking through the probability. I'll throw my hands up in the air sometimes, saying, hey, I'll let you know the probability of something cool. Thinking there's so baby, let's go. 52%. In a standard back for an aces, yeah, that's probability. 4 over 52, give me further reviews. 13, yeah, that's probability. Sometimes you wonder why it's so hard to accept. Your chances aren't real high. So many possibilities. It's exciting at the same time. Have a wonderful week, everybody, and I'll see you next week for some more fun. I will be leaving you some homework. Please make sure to do it. There will be an answer key once I take a look at each person's homework. Again, it's 20% of your grades. Make sure you do it just so you're successful in the course. I'm looking forward to it. Have a great week. Bye.